So now we add what we call rationalizing to denominators to the operations we're doing with radicals. First off, whenever we see a radical, two radicals in a fraction, we can put them together as one, or we can separate them into two separate ones. So that might not come up directly, but it's something that does work for us. When it comes down to rationalizing, that's when we have a radical in the denominator. We're going to multiply the numerator and denominator by that radical. And our goal there is to create a set. And that's what we saw when we were doing simplifying radicals. We want to create a set in order to take it out of the radical. So we'll start with 1 over the square root of a. If I'm going to multiply that, the top and the bottom by the square root of a, it gives me the square root of a on top because it's just 1 times that. But in the denominator, it's now going to be the square root of a squared. It created a set where we have a square root and we need 2 of them. That comes out to be the square root of a over a. We can look over an example of that. 1 over the square root of 2. I multiply the top and the bottom by the square root of 2. We have the square root of 2 on the top, the square root of 4 on the denominator. Well, that comes out to be 2. And this is what our goal here is whenever we rationalize the denominator. We can't leave an answer as an irrational in the denominator. We have to rationalize it because we're getting rid of the irrational and moving it up. It's perfectly fine if it's in the numerator. We're okay with that, but this is that simplifying we have to do. Now also, whenever we do multiply the top and the bottom by this irrational number, all we're actually doing is multiplying it by 1, but we're changing the way we look at that number, not changing its value. So what if I have b over the square root of a? Well, I still multiply the top and the bottom by the square root of a. I get b square root a over the square root of a squared, which becomes b root a over a. Again, our goal was to get rid of the radical in the denominator. 3 over root 2, same idea. We're going to multiply the top and the bottom by root 2. We get 3 root 2 over 2. If I went the square root of c over the square root of a, so now there's an irrational in the numerator. We're okay with that. That's not the problem. It's the square root of a on the bottom. So we multiply top and bottom by that radical. We then get the square root of a times c at the top and a in the denominator. Now this would be an example of a times c turned out to be a radical that you can simplify. You would have to go through that process, but not worry about it in this case. 1 over d root a. So now we have a coefficient on the radical. We do not need to worry about what the value of d is. We're again just focusing on the radical. We're going to multiply the top and the bottom by the square root of a in this case. So this would become d times the square root of a squared, which become the square root of a times or over a d, where that a squared in the radical becomes a, and we have the product underneath. This one I have an example with to the right. I have 1 over 2 root 3. The 2 is fine. It's the square root of 3 that I need to take care of. That's when I multiply the top and bottom by. I get the square root of 3 over 2 times the square root of 9. The square root of 9 is 3, so it's 2 times 3. So we get the square root of 3 over 6. What I'm not going to do here is reduce 3 and 6. Square root of 3 is an irrational number, 6 is a rational. They do not work together with these operations. We're going to leave it as it is. So now we come down to we have 3 root 12 over 4 root 7. We don't automatically have to look at rationalizing first, because really the bigger picture we're still doing is we're still simplifying terms and simplifying radicals. And where I would look first is the square root of 12. The square root of 12 is 4 times 3, which gives you a set of 2's. So this becomes 2 root 3. So I'm going to go 3 times 2 root 3 over 4 root 7. I can go further and say it becomes 6 root 3 over 4 root 7, which simplifies to be 3 root 3 over 2 root 7. Now, this is where I have to rationalize the denominator. I can't leave the square root of 7 down there. So I'm going to multiply the top and the bottom by the square root of 7. This becomes 3 times the square root of 21, because I can multiply the two numbers inside the radical. And then that's 2 times 7. Root 7 times root 7 becomes the square root of 49, which then becomes a 7. So our answer is 3 root 21 over 14. And again, we're not going to use the 21 and the 14 to reduce. If it's going to reduce, it's between the 3 and the 14. So simplify within the radical possible. It's still simplifying radicals as we've been doing, and then rationalize to complete the set. Now, what if we went from square roots to cube roots? Up here, I multiplied the top and the bottom by a square root of 7 to get a pair of 7s because it was square root. Down here with 12 over the cube root 5, if I just multiply the top and bottom by the cube root of 5, yeah, it gives me 2 5s, but as we remember, in cube root, we need 3 of them. So I'm actually going to multiply the top and the bottom by 2 more 5s. Our goal is to create a set. So I need 3. I multiply top and bottom to get that. So the top now becomes 12 cube root 25 over what essentially is the cube root of 125, but we know because we're creating the set, just becomes a 5. Now, 12 cube root 25 over 5 is the answer. What we want to look at real quick on a different example is, well, what if instead of 5, what if I had 12 over the cube root of 25? A little bit different, but we have to be careful what we pick to multiply. So I could multiply the top and the bottom by 25 times 25, but that actually gives me too big a value. Remember, 25 is 2 5s. I already have 2 5s there. If I multiply by 1 more to the top and bottom, I now get 12 cube root 5 on the top, and the denominator, I have my set, it now becomes 5. So let's say, well, what if you still wanted to keep 25? If you did 25 times 25 to the top and bottom, you now have 12 cube root of 625 over 25, which does look different, but it's actually going to simplify down. 625 is 5 to the 4th. So a set comes out, it's going to be 12 times 5, cube root 5 over 25, which the 5 and 25 simplify down, so we eventually get to that answer. It's going to work and still get us there, but really we're then forcing ourselves to then go back and simplify more radicals when we already are doing as many as we need to. So let's look at some different operations where simplifying or rationalizing denominators show up. I have addition here. I cannot add these yet because I do not have the same radicals and just treat it as adding or subtracting the coefficients. So if we rationalize first, multiply the top and the bottom by the square root of 2, I get root 2 over 2. Same thing over here, I get root 3 over 3. Now from here, we've rationalized, we've taken care of that part of it, but we have to continue to simplify. These do not have the same denominator, so I'm going to multiply the top and the bottom by 3 on the first one, and the top and the bottom by 2 on the second. This gives me 3 root 2 over 6 plus 2 root 3 over 6. Now that they have the same denominator, I'm going to go 3 root 3 plus 2 root 3 over 6, combining the terms, making it one fraction. I left off a number. That should be a 2. Now, these are not the same radical. I can't combine them. You can't force them together. This would be our answer. And just leave it as that. Okay, well, what if we went 7 cube root 4? This is just like the answer we had, or similar problem we had right here, where I had 25. 4 already has 2 2's in it. So I'm not going to do 2 more 4's to complete the set. I want to find the easiest set possible. So by just multiplying the top and the bottom by 1 more 2, we get 7 cube root 2 over the cube root of 2 times 2 times 2, which becomes 7 cube root 2 over 2. And that's the answer we want to get to. All right, well, now we have 5 cube root 18. 18 is not a perfect square. 18 doesn't have the same sets because 18 is 3, 3, and 2. So this one, let's say, all right, 18 times 18. Multiply the top and the bottom there. So now I have 5 cube root of 324, which is 18 squared. And then the bottom is 18, so at least served that purpose. Now we have to look to see if we can simplify 324. So I'm just going to write this off to the side. 324 we know is 18 times 18. That means it's 2 times 9 and 2 times 9. So you get a set the 3's there. Now this is cube root we're looking for. So I need to find a set of 3. I got it right there. So that's going to come out, and I'm left with 2, 2, and 3. That's going to be 12. So this becomes 5 times the quantity 3 cube root 12 over 18. This is then 15 cube root 12 over 18, which the 15 and 18 are coefficients. I can simplify those. That's going to give me 5 cube root 12 over 6. Now over here we have the fourth root of 5/8. Let's change that to be the fourth root of 5 over the fourth root of 8. I'm not going to multiply 3 more 8s to the top and bottom. I'm going to complete the set of 2's, because 8 is 2 times 2 times 2. So in doing that, it saves me from having to simplify more. We get the fourth root of 10 over 2. Down here we have addition again, kind of like this problem up here. We have to get them to be the same. If I look first at 1 over the cube root of 4, that is 2 2's. So I'm going to multiply the top and the bottom by 1 more 2. And that gives me the cube root of 2 over 2. So let's bring that down. Now, 1 over the cube root of 7, I'm going to multiply the top and the bottom by 2 more 7's to create a set of 7's. And that's going to become the cube root of 49 over 7. So I've rationalized both fractions. Now I need to combine them. They need to have like denominators, so I'm going to multiply the top and bottom of the first fraction by 7. The second one, multiply them by 2. So I have 7 cube root 2 over 14 and 2 cube root 49 over 14. Put them together, 7 cube root 2 plus 2 cube root 49 over 14. Last one, now it's suddenly multiplication. What you want to look for here is I don't need to simplify or rationalize first. I'm going to multiply them together. I get 10 over 3 root 40. Now square root of 40 is 4 times 10, so I can take out a 2 and leave it as that. So now I have 10 over 3 times 2 root 10. Let's just call that 10 over 6 root 10. The 10 and the 6 will reduce, become a 5 and a 3. So I have 5, 3 root 10. Now this is something you could have been able to do before this section where we talk about rationalizing. We would have gotten to this point. Now we have to finish the problem. Multiply the top and the bottom by the square root of 10. 5 root 10 over, this becomes 10, so that's 30. We get 5 root 10, oops, let's reduce. 5 and 30 leaves me with 1/6, so that is root 10 over 6.